Okay, now let us do chemistry, acids and bases topic. This is a topic that many learners consider the most intimidating. So like this is a topic that a lot of learners find to be the most difficult or the one that they struggle a lot with. So yeah, we're going to be tackling one of the questions from previous year's question papers regarding acids and bases. Okay, so I'm going to be talking a lot in this video because I'm going to be explaining a whole lot of things in just this video. What I'm saying? So I hope that you're going to enjoy it, and most importantly, I hope that you're going to learn one or two things in this video. Okay, so without wasting any time, let us get into it. So I chose 2016 May-June question paper, and this question was question 7, right? So 7.1 said hydrogen carbonate ions react with water according to the following balanced equation. So let us write the balanced equation. So it is the hydrogen carbonate ions, so HCO3 minus in aqueous. Of course, it is in solution, that is why it's aqueous. So I'm not going to write the state of that. And then it is reacting with water, of course, to give us the acid and the hydroxide ions, right? So this is the balanced equation, right? Okay. So I don't know if I should analyze the equation first before I get to the questions, or I should just go to the questions already. I like analyzing information that I have, so I think let us analyze the information first. I hope that you remember all the principles that we have learned in chemistry regarding acids and bases. So if there's anything new that I'm gonna be saying in this video, please let me know so that I can try to explain it maybe in a different way. Okay, so if there's anything that I'm gonna say in this video that you're going to find new, then please let me know so that maybe I explain it in a different way that you're going to understand. Oh my god, my PC is slow. Let me charge my PC real quick. Okay, right, so this is an acid and a base. Because we are doing acid and bases, we're going to consider this equation an acid and base reaction. Okay, right, so which one is the acid and which one is the base here? Remember that we're not doing the questions yet, we are analyzing the information, so we have to ask ourselves which one is the acid and which one is the base here. Okay, so we have to define acid and base according to the theories that we have learned. We have learned two theories that are going to help us to define a base and an acid. So according to one of the theories is the Arrhenius theory, and the second one is the LB theory. Well, I call it LB, but it's a Laurie-Bronsted theory, right? So those are the two theories which we're going to utilize in grade 12 to define an acid and a base, right? So we're going to utilize both of them. So according to the Arrhenius theory, an acid is a substance which, when it is added into a solution, the concentration of the hydronium ions increase. I'm going to repeat that. So according to the Arrhenius theory, an acid is a substance which, when it is added into a solution, the concentration of the hydronium ions increase. And according to the very same theory, a base is a substance which, when we add into a solution, the concentration of the hydronium ions, or not actually the hydroxide ions increase. Okay, so let us write that down real quick. I'm gonna erase this because I don't have enough space. Okay, but I want us to remember that. So an acid, according to Arrhenius theory. So this is according to Arrhenius theory. I don't even know if I'm gonna get the spelling right. Like the spelling doesn't even matter. Right. So according to Arrhenius, I don't know if the spelling is right, but it doesn't matter. Okay. So acid is a substance. This is just a revision. A substance which, when added to a solution, the concentration. Let me say the concentration of the hydronium ions increase. Okay. So this means concentration of the hydronium ions. Okay. So it's a substance which, when added into a solution, the concentration of the hydronium ions increase. And a base is a substance which, when added into a solution, the hydroxide ions increase. Okay, so I'm just trying to make sure that I remember all the information that I have regarding acids and bases before I get to the questions, right? So I call this an analysis. So this is what you should do before you get to the questions. Okay, so don't rush into answering the questions, right? I'm really worried about the spelling. I know that it is wrong, but I don't remember what the spelling of Arrhenius is, right? So this is according to Arrhenius theory. Now, according to LB theory, which is Laurie-Bronsted, which I call LB theory. According to Laurie-Bronsted theory, an acid is a proton, which is hydrogen ion donor. So it donates Okay, so it donates a proton, and a base is a proton acceptor. Okay, so this is information that you already know. I was just trying to make sure that you remember this information, right? So according to Arena's theory, an acid is a substance which, when added to a solution, the hydronium ions increase. This is according to how I understand it, or according to my own definition of this. However, the exam guideline might actually give you a different definition, but we're basically saying the same thing. Okay, so a base, according to Arena's theory, is a substance which, when added to a solution, the hydroxide ions increase. And according to LB theory, acid is a proton acceptor. Proton donor, very simple, and a base is a proton acceptor. So I hope that you still remember this information. So we're going to need this information in this question. So I'm gonna erase that. Hopefully you're gonna remember it, because I'm gonna be talking a lot about it during the course of this whole video. Alright, so this is one topic that a lot of learners find the most intimidating. Okay, so this is the topic that, if we had to ask learners which topic do you find the most difficult, they was gonna say acids and bases. I want to make sure that you I explain everything in detail. Okay, now that we remember the acid and base definitions, let us get to our equation. Okay, so we have to identify a base and an acid in this equation, because this is an acid and base question. So we have to identify an acid and a base. Okay, so when you look at this equation, is it the hydronium ions or the hydroxide ions that increase? Is it the hydronium ions or the hydroxide that increases? It is the hydroxide ions that increases, because we do have the hydroxide ions as one of the products. That means the hydroxide ions increase, right? So that means that the fact that we have hydroxide ions increasing means there must be a base that has what? That has caused that increase in hydroxide ions. So what is the base on this side here? What is the base? According to Laurie Bronsted, or according to LB, pick what I said. I said, according to Arenas, a base is a substance which, when added into a solution, increases the what? The hydroxide ions. So we have identified that, or we have determined that the hydroxide increases because it is the one that we see on the product side, according to Arenas. So Arenas theory has helped us to determine that it is the hydroxide ions that has increased. That means that there must be a base on the left hand side or on the reactant side that has caused this increase in the hydroxide ions. So we want to know, what is that base? So we're going to utilize the Laurie Bronsted theory to determine that base, or to identify that base. So see how I'm utilizing those both theories to help me to understand or analyze my equation. Okay, so I have utilized the Arenas theory to determine that it must be a base that has caused this increase in hydroxide ions. But what is that base in the reactant side? We're going to utilize the Laurie Bronsted theory to determine or identify the base on this reactant side. So according to Laurie Bronsted theory, a base is a proton acceptor. That means a base is the one that has accepted what? It is the one that has accepted a proton, which a proton is a hydrogen ion, which is an H+. Okay, so which one between this hydrogen carbonate ion and water has accepted a proton? That means its hydrogen atoms has increased. Okay, so when you look at the product side, we have the hydrogen carbonate here, right? So we have this hydrogen carbonate here. So this hydrogen carbonate has two hydrogens. Of course, we still have the carbonate, right? But we have two hydrogen atoms. On the reactant side, we still have hydrogen carbonate, but as ions. But there was only one hydrogen atom. So the fact that there was one hydrogen atom, and on the product side we have two, that means this must have accepted what? Must have accepted a proton or a hydrogen ion. Okay, so the fact that we have actually identified that these have accepted a proton to become hydrogen carbonate and no longer an ion, that means this must be a base. It has accepted a proton or a hydrogen ion to become hydrogen carbonate and no longer an ion, right? So that means that this must be the proton acceptor. According to Laurie Bronsted, a proton acceptor is a base. That means this must have been the base in this equation. Okay, so I just wanted to make sure that I identified the base and an acid in this equation that we have here, because we have the topic acids and bases. So see how I've actually managed to do that. Okay, so I hope that you have managed to understand how I've identified this as a base. Okay, the fact that we have this as a base which has accepted a proton from what? From water. So water has lost the hydrogen ion, right? So because it has lost it, that means it has donated it. That means this must be the acid. Okay, so that means this must be the acid. So we're going to call this base 1. Okay, and we're going to call whatever that corresponds with the base 1, we're going to call it acid 1. Okay, so since this has accepted a proton, it must be the base, but whatever that is going to form must be the acid. Okay, so this has accepted the proton and it is the base 1, but what did it form after accepting the proton? It has formed what? It has formed the hydrogen carbonate. So this hydrogen carbonate must be the acid. Okay, so this must be the what? This must be the acid. So this must be the acid 1 because it has been formed by base 1. Right, so that means water is going to be acid 2 because it has lost a proton or it has donated a proton, which according to Laurie Bronsted, we said that an acid is a proton donor, right? So that means this water must have formed what? It must have formed what? It must have formed this hydroxide ion, right? By losing that proton, right? So that means it must have formed base 2. Okay, so acid 2 has formed the base 2. Base 1 has formed acid 1. Okay, so what I've done here is identify the conjugate acid base pair or base acid pairs. Okay, so these are the conjugate acid base pairs. Please remember that I have not yet gotten into answering the questions. This is just the analysis. So this is very, very, very important. Of course, when you are in an examination, you're going to spend less time than I've spent in this video, because here I'm explaining to make sure that you understand thoroughly, because this is one of the most difficult, according to how the learners view it. It is one of the most difficult topics. So I have to make sure that I explain everything thoroughly. Okay. So these are the conjugate acid base pairs that I've actually identified here. Okay. So that means this base 1 matches up with this acid 1, and this acid 2 matches up with that base 2. Okay. So we're going to write that formally. So far, I hope that we're still on the same page, and I hope that you understand everything that I've actually just explained here. I hope that you understand the analysis so far. Okay, so I'm going to erase this and I'm going to write this formally. Okay, so I don't like a mess, so I'm just gonna erase all that mess and write everything formally. So I hope that you're still following, and I hope that you are also making notes if this is information that you had not known before. I said that if there's anything new that I'm gonna say in this video, you should write it down as your notes. You should add it into your notes so that you may not forget it. Okay, right, so I said that this is base 1, right, and it has formed acid 1, and this must be the acid 2 forming base 2, forming base 2. Right, so what are the conjugate acid base pairs? So the conjugate acid base pairs are the following. They are the following. So we have hydrogen carbonate ion with what? With the hydrogen carbonate. And then we have what? We have water with what? With the hydroxide ions. Okay, so this is acid base pair number 1. So this is acid base, oh my god, acid base pair number 1, acid base, oh my god, I think I don't like it when the video is too long, so that is why I'm in a hurry and I make mistakes. I should actually calm down and relax. Yo, it's a lot explaining things. Anyway, acid base pair 1, and then we have acid base pair. Maybe let me say yeah, it's fine. We know that they are conjugate, right? So acid base pair number 2. Okay, so we're going to need this information maybe at a later stage, we don't know, but this is the analysis. So I hope that you have managed to understand the analysis that I just done here. This is very, very important. You should do this before you answer the questions. But you should, when you practice doing this a lot of times, this is going to be very, very simple, and going to just spend maybe a minute, just a minute doing this, and then you're going to get into the question. So you're not gonna spend a whole 10 minutes like I've actually spent in this video doing this analysis. I spent more than I was supposed to in this video because I was trying to explain to you so that everything becomes clear. Okay, but when you practice this every day or a lot of times, then this is going to be something that you're just gonna spend maybe a minute doing. You know what I'm saying? So it's not gonna take longer doing this analysis. Anyway, now let's get into the question. 7.1.1 says define an acid according to the LB theory or Lowry-Bronsted theory. So fortunately enough, we have already done our analysis and we have remembered what an acid is according to the Lowry-Bronsted theory. So let us answer 7.1.1. So 7.1.1, what is an acid according to LB theory? We said that an acid according to LB theory, acid is a proton what? Is a proton donor. So this is 2 marks. Imagine just writing acid is a proton donor, just this 5 words, and you get 2 marks, guys. Come on. Now let us go to the next question, 7.1.2. Write down the formula of the 2 acids in the equation above. Of the 2 acids, they want only the acid. So unfortunately enough, we have already done our conjugate acid-base pairs, and we have identified the acids and the bases respectively. So we know that the acids are water and the hydrogen carbonate. So let us write our formulas. So they are water, H2. They said the formula. Remember that they said the formula. They didn't say the names. If they said the names, we was going to write water and the hydrogen carbonate in weight, but they said the formula, so we have to write down the formula. So it's H2O and H2CO3. So that's 1, 2. So far we have acquired 4 marks. We have obtained 4 marks. Look at how we have got our 4 marks just by answering. We haven't even done anything at all. How much is this worth? This is total 17. We already have 4 marks. So what is 4 out of 17? So 4 out of 17 is 24%. Because when you multiply this by 100, we're going to get 24%. And we say this. Oh my God. Okay. 4 out of 17. So 4 out of 17 is multiplied by 100. That's 24. So we already have 24% out of the total of this question. Okay, that means you're almost there to level 2. You know what I'm saying? So yeah, let us go to the next question, 7.1.3. 7.1.3 says write down the formula of a substance in the reaction above that can act as an enthalide. Remember what an enthalide is? Enthalide is a substance that can act as both an acid and a base. However, not in the same equation or in the same reaction, in different reactions. And it's going to be reactions that are consecutive. That means going to be one reaction, then the other one is going to fall after that. Okay, so it's going to act as an acid in the first equation, then it's going to act as a base in the consecutive reaction, meaning the next reaction, the reaction that's going to fall after the initial one. Okay, so it's an enthalide, or what is it called? The other name is MP-protic, something like that. But I'm more used to the word enthalide than the other one, okay? So an enthalide is a substance that can act as both an acid and a base, but it's going to do that in 2 different equations. But these 2 different equations are going to be, or reactions, are going to be consecutive, meaning we're going to have one reaction or equation, then the other one is going to follow exactly after that, okay? Immediately after that, okay? So, yeah. So they sent us which one above is an enthalide or can act as an enthalide. So we have to identify it. So how are we going to do that? So we're going to be able to do that by saying, so water reacting with another water is going to give us this plus this. So it's going to give us hydroxide ion and the hydronium ion, right? So that means one has to be the acid 1 giving us base 1. And this one has to be the base 2 giving us acid 2. right? That means the hydronium ion is going to be the base in this example, okay? Right. But in another example, it is also going to be a base, okay? So that is why in this example, it is not going to be water, that's going to be an ampholyte. But let us look at this hydrogen carbonate ion and this hydrogen carbonate, okay? So let us look at them, both of them, okay? So with this one, in this equation, the hydrogen carbonate is an ion and it's a base. It's an ion and it's a base, right? What about if it had actually lost another proton? If it had lost another proton, we're going to have something like this. If it had lost a proton, it was going to have something like this. So it was going to lose the proton to water and it was going to form CO3, 2 minus or minus 2, then plus the hydronium ion. Okay, so it was going to be, because it has lost a proton, it was going to be acid 1, giving us what? Giving us base 1. This was going to be base 2, giving us acid 2. Okay, so look at this. In this equation, this was going to be an acid, but in that equation, it's a base. In this equation, the hydrogen carbonate ion is a base, and in this equation, it's an acid. So what did I say an ampholyte is? I said an ampholyte is a substance that can act as both a base and an acid, or vice versa, an acid and a base. So that means that is going to be the hydrogen carbonate ion. That is going to be an ampholyte in this example. Okay, but if we look at hydrogen carbonate, that is not an ion. When it reacts with water, when it reacts in water, if it happens that it's going to be an acid, for example, it's going to lose an ion, it is going to form HCO3 minus plus the hydronium ion, right? It is never going to be able to react again to give to become the base. Okay, so what's going to react again is this. Okay, so it's going to be acid 1 giving us base 1, right? So we're going to have base 2 here and acid 2 there. Then we're going to take it from here. So this is further going to react with water. So we're going to have HCO3 minus reacting with water. So it is going to give us CO3 2 minus plus the hydronium ion. Okay, so that means now this is going to become, because it has donated the hydrogen ion to water, is going to be the acid. So this is going to be the acid 1 giving us base 1. This is going to be base 2. This is going to be base 2 giving us acid 2. So if we look at this, I hope that you can see that. So when you look at this, look at how here the hydrogen carbonate ion is a base and here it's an acid. Okay, so that is why I'm saying that the hydrogen carbonate ion is the one that is going to be an ampholyte in this example. So I hope that I've explained it in a way that you understand. If not, then please join my classes so that I can explain to you in a most special way that you're going to that is going to be convenient for you, and that is going to accommodate your academic needs in terms of understanding this this question. All right. So the answer for this 7.1.3 is hydrogen carbonate ion, HCO3 minus. So that is how we get our 5 marks. Now let us go to 7.2. Many times, or in most cases, 7.1 and 7.2 are related. That means that you're going to need the information in 7.1 to answer 7.2. However, in this specific question paper, 7.1 and 7.2 are independent of each other. That means we don't actually need this information that we have given in 7.1 to answer 7.2. 7.2 is totally independent of 7.1. Okay, now let us go to 7.2 and try to answer it. Okay, so I'm going to pause the video and I'm going to continue on the next page because I don't have enough space. So please wait a second. All right, thank you so much for your patience. 7.2. So 7.2 says us, during an experiment, 0.50 cubic decimeters of a 0.0 0.10 moles per cubic decimeter. Hydrochloric acid solution is added to 0.8 cubic decimeters of a sodium hydrogen carbonate solution of concentration 0.25 moles per cubic decimeters. The balanced equation for the reaction is that. Okay, so they've given us the balanced equation and that information. So let us start with the balanced equation. One thing that I have to mention though is sometimes when I'm trying to play tricks with you or games with you, they are going to give you an unbalanced equation, which you're going to need to balance yourself first. That is a skill that we learned in grade 9. So sometimes they're going to give you an unbalanced equation, which you're going to need to balance yourself. Then after balancing it, you're going to need to utilize it to answer the questions. However, if you did not balance the equation properly, or you did not balance it in the correct way, that is going to affect your answers in the questions that you're going to answer after that. So you have to make sure that you balanced it correctly if they give you an unbalanced equation. Fortunately enough, most of the times they're going to give you a balanced equation. But sometimes, just sometimes, and rarely, they're going to give you an unbalanced equation. So please note that and please be aware of that. So it is not all the time that they're going to give you a balanced equation. Sometimes they're going to try you and give you an unbalanced equation. So I don't make sure that I mentioned that. Okay, so I don't have enough space, so let me actually just shift this a little bit to the left. All right, I think that's all right, that's perfect. So let us write the balanced equation. So we have sodium hydrogen carbonate in aqueous solution plus the hydrochloric acid, giving us the sodium chloride, which is table salt, plus carbon dioxide, plus water, of course. Right? So this is the balanced equation. This is a reaction that we learned in grade 9. If you do not remember that, I don't blame you. It's been way too long since we done grade 9. But this is a reaction that we learned in grade 9, where a base react with an acid to give us salt, carbon dioxide, and water. Right? So they've given us the values, right? What did they say? They said that during an experiment, 0.5 cubic decimeters of a 0.1 moles per cubic decimeters hydrochloric acid solution is added to whatever, right? So that means that they're giving us information of the acid and of the base, right? So what is the information of the base? We have the concentration of the base. So we know that this base has 0.1 molar. So moles per cubic decimeter is the same as molars, okay? So we can just say molars or moles per cubic decimeters. So because I don't have enough space, I'm not going to write everything in full. So I'm just going to be like just molar. So 0.1 molar of what? Of 0.5 cubic decimeters. Please remember that volume has to always be in cubic decimeters, which means liters. So cubic decimeter is the same as liter. So that is what we gotta convert the volume into every time. Fortunately enough, in this question, we already have it in cubic decimeters, right? So that's the information that we have regarding the acid. And then the information that we have regarding the base is that its concentration is 0.25 molars, and then it's what is it called? Its volume is 0.8 cubic decimeters. So that's the information that we have, right? So the question is, calculate the concentration of the hydroxide ions in the solution on completion of the reaction. So when they're talking about the completion of the reaction, they're talking about titration or neutralization. So because this is an acid and a base reaction, they're going to react with each other to balance or neutralize each other. Okay, that means it's either going to be the base balancing the acid or vice versa, the acid balancing the base. How are we going to know if it's the base balancing the acid or the base, the acid balancing the base? We are going to read the information that have been given. So they said, again, I'm going to read it very slowly. During an experiment, that amount of the acid is added to. The fact that they said the acid is added to means it is the acid that is balancing or that is neutralizing the base. Let me repeat that. They're telling us that during an experiment, that amount of the acid is added to the base. So the fact that they've told us that it is the acid that is added to the base means it is the acid that is neutralizing or balancing the base. So it is the base that is being balanced or neutralized. Okay, so we have to keep that in mind. So it is the acid neutralizing neutralizing the base. So this is very important. We have to keep that in mind.